We should write this one in the order like A, B, C. Okay. Yes. So it is like X, Y, Z complement. All right, girls. Then plus X, Y complement, Z complement. So once you multiply, girls, you can see all products now having all the letters present. So what we need to do now, we need to check, is there any duplicate term? Is there any
Yes.
duplicate term? Which one?
Number 2 and number 3.
Number
X,
2
Y,
and number
Y.
3. Correct, this one. Do you remember rule? X plus X is equal to what? It will be X. Am I right? Correct. So whenever you find now after multiplication, if you have any multiple term, repeated terms, you will ignore the one, or ignore, you will consider only one. You can say like that. You will consider only one and remove the remaining. You may have more than 2, more than 3, like that. So you need to ignore. You will consider only one time. It is because of, if it is double, so it will produce only single one. Okay, so we can ignore one, and for example we are not considering this, so our answer is X, Y, Z plus X, Y, Z complement plus X complement, Z complement. Until, is it clear to all of you? So guys, you can see now this function is basically canonical sum of products, SOP form. So hope it is clear what is canonical. So it was standard SOP. Now it is converted into canonical SOP. All right, girls. Now, girls, we can also find the minterms here. How can we find the minterms? Do you remember how do we write the regular variable or the complemented variable there? So same you can just write. So X, is it equivalent to 1? Y equivalent to 1? Z equivalent to 1? Then X 1, Y 1. What will be the Z here?
0.
Very good. Now X 1, 0, 0. Can you just read these? What are these minterms, girls? M7, M6, M4. Am I right? So this is the sum of minterm. So we can show this one, sigma minterms in the bracket in the order 4, 6, 7. So this form is basically sum of minterms. Is it clear to all of you? Getting the point?
Yes, correct.
Clear, right? So this way we just convert into canonical form. If the question come convert into canonical soft form, you should go up to here. If we ask find the minterms, so you have to go through all the process like that, all the process, and reach here. This is some of the minterms.
I have a question.
Yes.
Does it always like the same number 765? This is 4. The last one.
Which one? Which one is 4? Last one
The
is 4.
M7, M6, and M4.
Yeah, so it's depend upon the expression, which minterms are present in the expression. We may have another question. We can have another minterms present there. Getting the point?
I need to memorize each one. What's each one?
Yeah, how would you know these things? Because you know that how we represent the minterms. So equivalent to regular, we need to equate 1. Is there any complement? We have to equate to 0. Then we can check which number is this in binary. I think it is clear. You can easily check 1, 0, 0 means what in binary. Is it 4 or not?
Oh, yes.
Right? Yeah. So it's 4. 1, 1, 0 is what? 6. 1, 1, 1 is what? 7. So there are 3 minterms present. And it means is that, and you know what is the significance of it, what it is communicating basically. I'll show you this thing. So basically, what is the significance of this one? Just give me a minute. Let me just squeeze it if I can. Yes. So it means is that it signifies that, girls, if we have a truth table for this, basically these variables, right? So the truth table will be like that. How many variables? 3. So X, Y, Z. Now 0, 0, 0, 0, 0, 1, 0, 1, 0, 2, 3, 4, 5, 6, and 7. Now this is the output, the function, right? So if these minterms are there, you know what they are signifying? Basically, they signifies that whenever you have 4, which is this one, 4, the F is 1, yani minterm is present. 6, yani minterm this one is present, and 7, yani this minterm is also present. What about the rest? We have only 3 minterm present in the function. Remaining are basically 0, 0, 0, 0, and 0. So it signifies that. So once in the function, basically telling you the minterm present in the function. The 0 means missing minterms there. Are you getting the point?
Yes.
Okay. So for example, if you know this truth table, can you easily find the function or not? You will just check what are the minterm present, correct? For example, this one is present, so you will look here, you will see here, you will see here. So 3 product terms, and you can write the function like that. This is the function. So this is the importance of this minterm and maxterm. Okay, let's have one more example. So this is some of minterms. I believe it is clear to you. And now we can move to another question. Let's see this one. Convert standard product of sum to canonical, pause, and find the maxterms. Because pause means, you know, some terms, and it can give you the maxterms basically. So now starting from here, let's assume the question now. Let's suppose we have given f is equal to a b c, any function of abc, right? And we have given a plus b and a complement c. Are you getting? Question is clear? So when you see this question, I believe you can understand it is a product of some form. Okay. And product of some form, we have to convert it into canonical. And this is a standard form because the function is a function of ABC, but these two are having only what they are having. They are having only two literals, or sometimes it may have 1 literals as well. Keep in mind. Okay. So what can we do now? How can we bring all the missing literals here? So girls, can I just write it like that? Any problem if I put 0 there? Problem or not?
No.
No problem, right? And do you know 0 is equal to C into C bar, or 0 is equal to B into B bar? So what is missing we have to bring here actually. Am I right? Correct. So in place of this 0, what we are going to do, girls? We are going to replace with the missing literals like that. C dot C complement. Here A complement plus C plus what is missing here? B dot B complement. Till now, clear to all of you? Any question, any confusion?
Clear.
Clear, right? All right. Now, girls, do you remember distributive law? For your reference, I'm just writing here. What was that? Distributive law. A plus B dot C. How do we write the distributive law? Do we write like that? A plus B dot A plus C. Do you remember? Second form of the distributive law. Yes. Yes, Hanadi. So it is like what you said, it is for that X plus YZ. Okay. It could be written as X plus Y, as you said, dot X plus Z. Correct? This is something what you said. So did you get the point? What I'm trying to say now? Is it clear, right? So girls, can we just assume A plus B as a single unit? As a single unit. And C and dot C is like that in place of YZ. Are you getting my point? Should I repeat? Consider A plus B as a single unit. Okay. And C dot C bar consider as a Y dot Z. So can I write this way? A plus B single unit plus C dot A plus B as a single unit plus C complement. Is it clear to all of you?
Yes, clear.
Okay. So similarly, we have to go for the second part, second parenthesis here. So consider A complement plus C as a single unit. So what I should write? Tell me. Who will tell?
A complement plus C plus B.
Okay. Can I write A complement plus B plus C in an order
Yes.
tertib? Right?
Yes.
We know this thing, right? Right in the tertib. Okay. Next one. A complement.
B complement plus C.
A complement plus B complement plus C. Say like this, okay? Because plus is there. Now, can you see in each sum term, do we have all literal present now? Yes.
Yes.
So it means it is now canonical. But we have to check, is there any repeated term? If there is any repeated term, we have to consider only once. We cannot consider twice. So check it now. Is there any repeated term? I think no this time. No. Okay. So now, so this is a canonical form basically. So we have converted, we have given the answer of this. So this is now canonical product of some form. But we have the second part, find the max terms. So we can find the max terms also, girls. Now, can you just write what is a binary equivalent of each sum term here? Like A, for the A, what it should be?
0.
1.
0.
1, 1, 1.
No, dear. It is 0. Author, this is the change. This is basically max term. And how do we read the max term? Regular as a 0 and complement as a 1. Getting or not? I just explained, okay? This is the change. All right, no problem. What is next then? 0, 0, 1. Correct? Next, tell me.
1 0 0.
1 0 0. Correct. Next one.
1 1 0.
1 1 0. So now we can write the max terms. These are M0 dot M1 dot M4 dot M6, right? So we can write now in the form product of sum pi capital M, and in the bracket we can write in the tertib 0 1 4, 6. So these are, girls, the max terms. These are the max terms. Clear to all of you?
Clear.
Okay. So this way, sorry. Yes, yes.
Why did you say 0 instead of 1 and M capital? When do I like use this one and the other one?
So this is max terms, and I explained max term before this. Even I explained max term in last lecture, and here in this slide, I already discussed the min terms and max terms. These are the min terms, and how do we write the min terms? You can check. And these are the max terms. How do we write the max terms? It is there. And I explained, I remember in the last lecture this thing. If not, I have provided the recording, I believe. If not, so 0, 0, 0. How do we write the min terms? It is a product terms. So for 0, we have complemented variable. But for the max terms, for 0, we have regular. And for the ones, we have complemented notations with the plus sign. This is max term. Okay.
Yes, I got it.
Okay. And this is the capital letters for max terms. Clear now? Okay. Anyone? Any other students have question? Clear, right? So this conversion is, you will be having a question for that, how to convert this one. And now, just move to next. These questions we have covered already. Min term is what basically? When we say min term, girls, so it should be clear. It is basically canonical SOP. Min terms means canonical sum of product. When I say max term, can you tell me what is the meaning of max term? Canonical
of sum.
Yeah, canonical product of sum. It's not just a product of sum. It is basically canonical. Okay. So this is min terms, contains all variable. There is a AND function. Evaluate to 1 for a specific combination. I already explained to you. In the truth table, it is gonna be evaluate to 1 for a specific combination. For example, girls, if we have a function with a variable ABC, so there could be 8 possible, min terms. All are min terms mentioned here, M0 to M7. But which min term function is having is basically, depend upon the function at that time. For example, if I give you this truth table and I ask you, girls, can you tell me the function? So basically from this truth table, we can identify the min terms. Am I right? Can we identify the min terms from this table?
Yes.
Okay. So what are the min terms? Can you just tell me?
1, 2,
Okay.
3. Oh, no, it's not 3. 4, 5, and 7.
7. So 1, 4, 5, 7. So it's easy, means we can see where are the ones. It means they are min terms, and I can easily find the function now. How can I easily find? This way. So corresponding to this one, it is basically A complement, B complement, C. Because we know that how do we write min terms? We write with the 0 as a complemented variable and 1 as a regular variable. Similarly, because it is basically min terms, and min terms is always in a sum form, sum of min terms form. So another one is sum, and it is like A, B complement, C complement. Similarly, the next one is gonna be add, and A, B complement, C, and the finally is 7. So this way, girls, if the min terms are given, we can find the function, and if the function is given, we can find the truth table. This is like that, vice versa. And if we have asked to design this function, implement this function, yes, there are 4 product terms. We need 4 AND gates and 1 OR gate, and I can implement this function. Okay, so this is what a Boolean function from the truth table. Now, girls, this is another question, which is here conversion of the given term. So first of all, again, I'll explain to you this one. This is x dot x plus y complement. X dot x plus y complement. Okay, so do one thing. Go here. I'm just writing the question. I will solve for you. So function is given to you. F is equal to x dot, what was that? X dot, remember? Can you see and tell me? What was that? X dot
Z complement.
y plus z complement. Okay. It was y plus z complement. Y plus z complement. So guys, this is given to me. And I have asked to convert into canonical POS form, product of sum. First, when you see this one, can you check which form is this? Which form is this? This is basically POS form, but which POS? Standard POS. Shahad, standard. It's not the canonical one, right? So we'll say it is basically POS form. Okay, and now, so there are two sum terms. Girls, we can also consider this one as a sum term. Why? Because can I say x plus 0 and y plus z complement? So like sum, and then product. That's why you said product of sum. Okay. So we will look here what is missing and we have to bring that literal here. So how can we do this one? So with this x, girls, if we write like that, x plus 0, I believe there should be no problem. And here is what missing, girls. With y plus z complement, we can write 0 also here. Okay, so in place of 0, as I just explained earlier, we can solve it like that. So for the 0 here, we can write y dot y complement. Keep in mind, girls, we have to bring one literal at a time. If you want to bring x and y same time, you cannot bring it. Okay, so you have to go step by step. And the next one is y plus z complement. And what should I write in place of 0, girls, here?
X dot X complement.
X dot X complement. Absolutely right. Now, but we have to apply distributive law. So what it will be now? X plus Y. Correct, guys? And what is next? X
plus y complement.
Y complement. Absolutely right. Next. Now, here, as I just explained you before, consider this one as a single unit and then apply distributive law. So tell me what it will be. Will it be y plus z complement plus x? Am I right?
Y plus Z complement.
Absolutely right, Bayan. We have to write in an order. So rather than saying y plus z complement plus x, we can say x plus y plus z complement. Okay, that is easier for us because it should be written in this order. That's why you can find the min term and max term if it is written x, y, z, a, b, c. Okay, what about the next one now? Yes.
X complement plus Y plus Z complement.
Absolutely right. Easy, right? Huh? Yeah, you need to focus, bus. Then it's easy. Okay, now, girls. So now initial two terms we can see here is still we are having y, z missing. So can I say again z dot z complement? Any problem? Because z dot z complement means 0. Correct? Okay. Now move next step. Tell me. Is it correct?
Yes.
Okay. Next.
X plus Y plus Z complement.
All right. Next. Getting? Any doubt, any question, girls? Correct?
No.
Now, what is remaining? These two also. Write these two also. So, Just copying from the top. What is the next step, girls? Now we can see all the sum terms are having all represent. What is the next step here?
Duplicated.
Very good. We have to remove the duplicated terms. First, we need to identify where are the duplicate terms. Check it.
The second and the fifth one.
Clear? This one and but these two only, correct?
Yes.
So what we can do? We can cancel one term. Let's cancel this one, correct? Are you getting the point?
Yes.
Just cancel one, but we cannot cancel all. We have to cancel, but we have to consider only one actually. So remaining we can cancel now, girls. So this is my answer basically now. So we can say this is the canonical product of some form, but we may also ask find the max terms. So let's find the max terms also, girls. Okay. So what we have here now? 0, then 0, 0. Next is 0, 0, 1. 0, 1, 0. 0, 1, 1. It is already cancelled. 1, 0, 1. Just read them. M0, M1, M2, M3, M5. And how can we write the max term? By using pi and the capital M in the bracket 0, 1, 2, 3, 5. So these are the max terms which we are having. So this is the answer of this one, guys. Okay, up to here. Any problem? Any confusion? Any doubt? Any question?
All clear.
All clear. Very good. So now one more thing, girls. If I know the max terms, I can find the min terms. What I said? If I know the max term, I can find the min terms. How? The rule is what we will do? We will write function is equal to this pi will replace with the sigma. This is small m will uppercase m is gonna be replaced with this one, and in the bracket you have to write the numbers which are missing in the max term. It is a function of 3 variables, girls. So what could be the possible listing? It will be from 0 to 7 or not with the help of 3 variables. Correct? So you need to check what are missing there. Yes, Zainab, correct. So what is missing there, girls? 0 is there. Okay. Then what is there? 1 is there, 2 is there, 3 is there. So 4 will be coming here. 5 is there, 6 will be coming here. What is it? 7 will be here. So these are the min terms basically. And if you want to write as a sum of min term form, any equation form, you can also write in canonical sum of min terms. So we can say 4. How do we write 4? 4 yani we can say simply x, y complement, z complement. 6, x, y, z complement plus x, y, z. So this is sum of min terms or canonical SOP form. Yes. Confusion or clear? I believe it's simple. Just we need to, write the missing terms, replace pi by sigma and small m by. And girls, it works vice versa. How it works? Vice versa. So if you know the min terms, you can also find the max terms. Clear to all of you? Okay, so now move to the slide, girls. And it was the question I already explained to you. This is max term. And max term is what? Basically, whenever you heard the name max term, yani we are talking about canonical product of some form. It consists of sum or function, contains all variables. This is the rule. Evaluate to 0. Min terms, girls, min terms evaluate to 1. And do you remember I mentioned that min terms are the complement of the max terms and the vice versa. So for the min term, we evaluate once in the table, but the max term is going to be evaluated as a 0 in the table. Getting the point, girls? So for example, if we have 3 variables, so possible max terms are like that. Okay. And if you want to write the function, we can simply write the function according to the given function. For example, this one. So here what we have 0, 1, 2, 3, 5. Okay. So in place of these, basically, what we are going to have? We are going to have 0 and the remaining is going to be 1 in the truth table, actually. You know, this work like that. Because now see this next. What is this one? So question will be coming like that. Obtain the canonical sum of product form of the following function. So girls, what they are asking, sum of product form. So you can see here, this is A plus BC. Which form is this? Sum of product form. So here in the first product, what is missing? A is missing and B is missing. Sorry, B and C, correct. And the second term, A is missing. A is missing, right? So what? How can we write this one, girls? I can write it like that: A dot 1, and here I can write 1 dot BC. In place of this one, we can write A, and it is basically dot. We can write B plus B complement. Okay. Then in the next step, we can write the C plus C complement, but they are writing same time. So we can also write C plus C complement. So we know that they are going to be equal to 1. And here is A plus A complement. Okay. And in the bracket BC. So girls, but we know that we cannot multiply all the brackets at a one time. What we need to do, we go step by step. So multiply these two first. When you multiply, you will be getting AB plus AB complement. What is remaining now? C plus complement is remaining. So next step, we have to multiply that one. But here with this one, we can directly multiply ABC and A complement BC. Now multiply these two braces together, parentheses together. So ABC and ABC the next one is ABC. Now ABC complement and this complement and this one and this one. Now you can see this is all the letters present in the term. Okay. Now we have to check what are duplicate. We have to remove that one. So just after removing, we are having this function finally. Then hence the canonical sum of the product expression of the given. So this is the sum of canonical sum of the product expression here. Okay, guys, is it clear to all of you? Right. So these are the type of questions which are coming to you, and you have to convert one to another this way. All right, guys. So this is the conversion which I already explained to you. How can we convert one form to another? Okay. So interchange the symbols sigma by pi and list those numbers which are missing from the original expression. For example, we have this function, we can find the min terms, and these are the min terms. We want to convert into max term. Girls, so simple. What you need to do, pi 0, 3, 5, 7, and it could be written as A plus B plus C dot like that, dot like that. And here is the correction. Please do correct. It should not be plus, it should be dot. Just correct this one. So this way we can change one form to another form. All right, I already explained this point. Now, okay, see this question, girls. Conversion between canonical forms. So express the Boolean function as a product of max terms. So this question is good question. First of all, they are asking product of max terms, yani canonical pos form. Which form is this, girls?
Sum of products. Standard sum of product.
Standard
Sum of product. And what they are asking? Product of max term. What is product of max terms? Do you remember? Canonical product of sums. Am I right? But the equation is given SOP. Okay. So now tell me, how can I do this one?
We solve it for SOP and then convert.
So SOP is already there. Yani convert into canonical first. Are you saying like this?
No, I can solve for sub and then convert.
Oh, okay. What I'm saying, what you are saying, it is a standard form, right? So you have to convert into canonical form first. Canonical SOP. Okay. So what is missing? You have to just convert accordingly. So here we can say f is equal to x, y. So here we can say what? Z plus z complement. Similarly, x complement z. What is missing? Y plus y complement. So we can go x, y, z, x, y, z complement, x complement y, z, x complement y complement z, girls. Okay. Is there any repeated term? No. So we have to find product of max terms basically. So here we can list what are these. This is like, which number is this? 1, 1, 1, 1, 1, 0, 0, 1, 1, 0, 0, 1. So I can say sum of min terms. Okay, like sigma m in the bracket, like 1, 3, 6, 7 in an order. Okay. Now convert into find the max terms, and you know that one. How can we do this one? So this function is gonna be now pi m and list the missing. What it will be? 0, 2, 3 is there, 4 and 5. Correct. And how do we write these? 0, 2, 3, 4, 5. So just list accordingly. So we'll be writing 0. How will be writing 0, girls? X,
Y, Z.
X. Why are you missing 5? Oh, sorry. Plus. How can you ignore plus? X plus Y plus Z. It is max term. And max term is basically canonical product of sum. Now 2. How do we write 2? 0, 1, 0.
X
Zero.
complement.
No, it's 0, 1, 0. And it is max term. Don't read like min term. 0
Y
means
complement x plus y complement plus z.
next is gonna be 4. Next is gonna be 5. So how do we write x, y complement plus z? Right. Now x,
Complement plus
X
y plus z.
complement plus y plus z.
correct. Now
X complement plus y plus z complement.
that's right. So this is my answer, which is now canonical, or we can say product of max terms. Now check this one. So sum of min terms basically. Here is the expression given. And from this expression, we can find the truth table. We can list the minterms there. Okay. Similarly, what can we do? See this. These are the minterms, which is like 1, 4, 5, 7. These are the sums, and 1, 4, 5, 7. In place of that, we can place the ones. So hope it is clear to you what are minterms. Minterms are gonna be equivalent to 1 in the truth table basically. Product of max term, what are these basically? These are the basically the missing terms which are not there in the which are not present in the minterms. So equivalent to that one, what we are going to have? We are going to have 0. Can you check in the truth table? 0 in place of number 0, 2, 3, and 6. So these are minterm and max term, a part of basically output of in the truth table. Okay. Now, girls, how can we implement these basically these product of sum of product forms? So as I explained to you already, we see how many products are there. So we see 1, 2, 3 products. So corresponding to 3 products, will be having 3 AND gates, and overall it is a sum basically. So 1 OR gate is sufficient. So we can write there. So for the B complement, we can have also, girls, the NOT gate, and then we can show that one. Okay. Sum of product implementation. 2 level. 2 level yani, how do we call the levels? Level means this is considered as a 1 level, and this is the another level. 2 steps, you can say. Okay. 2 level. If we also use the NOT gates, so it is not gonna be 2 level, girls. It is gonna be 3 levels, because in place of B, if we connect the NOT gate here, for example, okay, so it is like 1 NOT gate. So we will be giving here B as an input. Okay. Similarly, one more, this B is there, so we can just connect it like that. So it is like now 3 level implementation. Yani one step is this one, this gate, okay, up to here, then 2 and 3. So they are saying 2 level, so they just skip the NOT gate concept. So it's like 2 level implementation of sum of products. Now, girls, similarly, product of sums. So because finally it is product of sum, so for the sums we need the OR gates, and overall this function is basically a product. So 1 AND gate is sufficient. So 2 level implementation of the product of sum forms. Is it clear, girls? Implementation to all of you?
Yes.
Okay, because we have to design the circuits also again and again, so it has to be clear to you in your mind what is the meaning of 2 level and how can we implement sum of product and product of sum forms. Now, as AND gate, you know already very well. So x, y are the inputs and output is x dot y, and this is the truth table. NAND, not AND. So the output is complemented here, girls. I believe that you are well aware of it. NAND gate. So what is that here? The output is complemented here. So you can see we have a 0, 0, 0 here, and NAND is basically not AND. So here we have 1, 1, 0. Okay, this is x dot y.
Can we consider the NOT as a level and the AND as a level, or it's just one level?
It's just one level because one gate, no? So there is no this just gate yani itself telling you the level. So if we have only one gate and just one level. And if you have 2 back to back, then we will say 2 level. Okay, this level. Now OR gate. So OR gate symbol is that, and whenever you draw these things, girls, be careful. Your draw must be clear, neat, and connection must be proper. You cannot leave the lines, the break lines anywhere. Or then we have not or. It means the bubble is there. You can show this one. So not or. So we have this one. Not or. So x plus y we have here, but here we have a complement. And do you remember when we apply this De Morgan theorem? Can we apply De Morgan theorem here? If we apply, what we can have? X complement.
Dot x complement dot y complement.
Absolutely right. Yes, we can also write these things like that. Yeah. It's like that. Very good. So because we are going to use the De Morgan theorem also after some time. Now, exclusive OR gate, it is like this one. So one extra line at the input, which you can see, and this operator is plus inside a circle, which is exclusive OR operator. And it is like x complement y plus xy complement. And whenever inputs are different, then only output will be 1. Similarly, another one, XNOR, exclusive NOR. So it is like you can see the difference. There is a bubble also. It is an invert of the exclusive OR gate. So X plus Y, and then we have the top bar. If we remove it, we'll be having X dot. This is the exclusive NOR operator, and it could be written as XY, X complement Y complement plus XY. And it is opposite of it, as we know, because there is a bubble. So whenever inputs are similar, then only output will be 1, else it is going to be 0. So this way, this is NOT gate, girls. You know very well about the NOT gate. Buffer, girls, is just to boost up the signal. It is not going to be changed whatever you apply at the input, but sometimes signal become weaker when they travel long distance. Okay, so buffer is used to just boost the signal. So input and output is same. So if 0 input, output is there. 1 is there and 1 is there. Okay, so buffer gate. Next, these are some exercises, homework for you. You need to practice all these which is mentioned here.